We're now going to take a look at a form of refrigeration that is quite different from the two processes that we've looked at, both vapor and gas refrigeration cycles. What we're going to look at now is one that includes no moving parts or any working fluids, and it is referred to as being thermoelectric cooling. And sometimes you'll see it referred to as TE for the thermoelectric. And basically the premise under which this is operating, it's kind of like a thermocouple operating in reverse. So let's begin by looking at how a thermocouple works. What a thermocouple usually involves, or always involves, will be spot welds on two dissimilar metals. So we may have these two dissimilar metals and we spot weld them together at either end. This is then referred to as being junction 1. And this would be junction 2. If we put these, first of all, I should put the metals. So this would be metal A. And this here is metal B. Now, if we put junction 1 at temperature 1, and we put junction 2 at a different temperature, temperature 2, a very interesting thing will occur. And what that is we will get current flowing through this loop. So if we then put in an ammeter, enabling us to measure current flow, it will give us an indication, and the amount of current flowing will be proportional to the difference in temperature. So if we know one of the temperatures of the junction, we can then, knowing the current flow, determine the temperature of the other junction, and that's how we use this as a thermocouple. But in order to do that, what we need to do is maintain the two junctions at different temperatures. Now this process is referred to as being the Seebeck effect. And it is actually what is used on the Voyager spacecraft, both Voyager 1 and Voyager 2. There's a radioactive isotope that is decaying, and it's at a hotter temperature, or a larger temperature than the surrounding space. Voyager spacecraft are far out in space now, and consequently it's very cold and a very low temperature. And that temperature differential is then used to provide this current flow, which provides power generation on the spacecraft. So it provides for a way of generating power. It's a nice power source given that there are no moving parts. You can use it in very remote locations, the Voyager spacecraft being one, but others, if you're in remote field locations where maybe you have a supply of natural gas, you can have a flame and then it goes into the thermoelectric generator and can generate power for you. So we use the same system or idea to measure temperature. So you can use it for power generation or you can use it for temperature measurement. Now, What we're interested in here now is cooling, refrigeration. And so it turns out that you can operate this device in reverse, where you put a current into it and you will achieve a cooling effect. So again, you have two dissimilar metals. And let me erase the lower one because I want to put something in it. I want to put a power supply in here. So we would have a battery that induces a current to flow in our loop. And what we will find is that if we have one of these systems, heat will be absorbed at one side. So that is, it will be at a lower temperature than the surrounding environment. And heat will be rejected at the other side. So it will be at a higher temperature than the surrounding environment, and consequently we have heat transfer away. And that is the basic idea of refrigeration that we have going on there. So in order to make this system work, what we need to do is apply a DC power source. And this is named after a fellow named Peltier, who came up with the idea in 1834. And you'll hear sometimes referred to as being a Peltier or thermoelectric cooler. Now, it's not the most efficient process. It does consume quite a bit of current. You have to source a lot of current through it. But nonetheless, for certain applications, it does turn out to be highly effective because it's very compact and no moving parts. So in the next segment, we'll take a little more detailed look at the thermoelectric cooler.